it's time to put our knowledge together to build a local search topology where we can connect to Twitter on one side and Elasticsearch on the other side and index the tweets in real time and see if we can search the tweets in near real time. So this is how we are going to build the topology. So we will say we are going to build local search topology, right? So you have like Twitter on one side, right? We want the ability to get the content from Twitter, right? So we have created a Storm Spout, which is basically a connector to Twitter, and we are saying give me Twitter with the filter only all the tweets which contains COVID-19 text. So I'm going to get a stream of tweets and I'm going to create one Elasticsearch bolt which basically receives the tweet from the Storm Spout and it extracts the relevant fields like the tweet text, user, the date on which the tweet was created, and the retweet count. These are the only fields that we extract, and then we write it back to an Elasticsearch index. Okay, and then we can query this Elasticsearch to get the tweets. Okay, that's what we are going to do, and we are going to use Postman for now, but later on we will build a web application also. So this is the topology we are going to build, right? Now, one of the advantages of the Storm Spout is we can do parallel processing. So right now here you can see there is only one ES bolt, but in reality we can connect multiple instances of this ES bolt, right? Not only one, two, you can have as many as you want depending upon your capacity, and all of them can write to the same Elasticsearch. This is especially useful when really you want to scale your applications. Let's say your Twitter is sending the data at a very high rate. The usual rate is usually for the Twitter is, not surprisingly, it's maybe around 20,000 messages per second, or could be more, right? So we would need to parallel process all the tweets and then write to the Elasticsearch cluster. If our cluster is very powerful, like if it has multiple nodes, then we can scale this Elasticsearch bolt by adding just more containers and increase the throughput of your system. So we will start with one spout and one bolt, and later on also I will demonstrate how can you have multiple bolts. We can just extend our example. So let's try to build that. So I will go back to my Java. Right. First, let me walk through the code and then we will run the code. So first thing that I'm going to do is build a Twitter spout. Okay. And we are going to reuse a lot of code that we have done earlier. So a typical spout, Twitter spout, we are just going to extend. So we will start using the Apache Storm library now. So we have imported the Apache Storm packages. Also in the POM file, if you take a look, we have added the Apache Storm jar and imported all the packages. So you just import the various Storm packages, right? And then you create a class which implements the base reach spout class. So this is the class we are going to extend and override the methods, right? Now most of the code would be will seem familiar to you, which is used for connecting to Twitter. The only difference in the example is we have added the implementation of a base reach spout method. So let's look at it. So the first method that gets executed when you initialize Storm Spout is that open. So open is like an initialization method that gets called only once during the life cycle of a Twitter Storm topology. Okay, so you can write your all initialization code here, and you can get reference to your configuration, the context, and the output collector if you want to use. So the first thing that we do is we get a reference to the collector and store it locally, because this is the collector where we want to emit the stream that we want to send it to the bolt. Then this is the usual code where we want to connect to the Twitter. You have seen this earlier. And then we just establish connection using this code, and also we initialize the queue where we want to put our tweets, right? And then we implement listener for the status listener. So the status listener will get executed every time we get a new tweet, and the only thing that we do is we put the tweet, the entire status object, into a queue. We do not implement any other methods, as we similar to thing that we saw earlier. Then we hook up the listener that we just created to this Twitter stream, and also we created a filter query. We don't want all the tweets from a Twitter. We just want a Twitter which has COVID-19 in the text, and then we just attach the query. So we just created a Twitter stream object and initialized in that open method. So as I said earlier, open method gets executed only once during the Storm lifecycle of a spout. Once that happens, okay, then the next tuple is a method which will get executed regularly, right? So whenever we need next tuple object, so this is the method that will get executed, and we are going to output a tuple. So this is the method that will get called by the topology to get the new tweets. Okay, and what we are going to do in this method is we're just going to get the tweet from the poll by polling the queue, and then we are just going to emit it out to the downstream bolts. So the connection between the spout and bolt is not done here, it is done in the topology. But this bolt, all it does is it just establishes connection with the Twitter during the initialization, and the next tuple method, this gets executed regularly once our topology starts, and all the topology does is it keeps polling the queue and sending the data out to the downstream system. Then in the we also need to define the schema in which we are going to send the output. So right now we have just defined a one field which is called tweet, and this tweet contains the whole status object. Okay, the status object has fields like user, tweet, retweet count, when the data is created, and things like that. So all the entire status object will be there in the field tweet, and then downstream systems can know that this is the object they need to get the status object. And finally, once the topology is shut down, we are going to call the Twitter stream.shutdown method. Okay, so again, just to recap, open method of Twitter spout get executed only once, where we can just put initialization code. Then the next tuple method is going to get executed by the topology continuously, right? So what we are doing is here is we are just polling the queue, get the message. If the message is not available, we just sleep for a few milliseconds, and then keep emitting the messages to the downstream system. So this is the Twitter spout. Now let's go to the ES bolt. So ES bolt is the one which will receive the stream from the spout, and it will write to the Elasticsearch. So ES bolt, we usually extend it from a very basic bolt, and just like spout, we override few methods like prepare, cleanup, and execute. So the methods are very intuitive. So prepare gets executed only once, just like open in spout, and we can put the initialization code here. So all here I'm doing is I'm initializing my doc counter to 1, which counts the number of documents that I'm indexing. Then I'm creating the new instance of Elasticsearch and just keeping a reference here. Then similarly, cleanup method that gets executed once the topology is shut down, and I'm just going to close the connection to the Elasticsearch client. Now this method, execute method, again just like next tuple method, gets executed every time we receive a stream from the spout. So the stream that we receive is encompassed into an input object, and this is the collector object where we, again, if you want to send to the further downstream system more bolts, if we have in our system, then we can use this object. So in this execute object, the first thing we are going to do is we will get what as bolt has sent us, right? So it was sent in the tweet field, right, that we saw in the bolt, and we also do the same output field declaration here. So our schema that we define here, we matches with the schema in the spout. So from the input tuple, which is nothing but an input stream coming from our spout, we extract the whole status object, which is the tweeter. Then from this status object, we extract fields that we are interested to index in Elasticsearch. So we get the tweet text, retweet count, the actual user name, and the date on which we created. And I'm just getting one more field which you are not using, like a profile URL, but I'm just going to just keeping it there for your reference. Then I'm going to put all the fields that we have extracted into a JSON map, where I put this is the Elasticsearch document basically we are creating. The key is the name of the document, key, attribute, and the value is the actual value. So I'm creating this map of key value pair which represents a document in Elasticsearch, and then I'm going to call the client.insert method to insert this document into the Elasticsearch, and the Elasticsearch will give me a document ID, and then I'm just going to print it out. Okay. And I'm going to increment the document count every time we process the document. Okay, so this method will get executed again continuously as long as our topology is on. So every time we receive tuple from bolt, this will keep executed. So we have created a spout, we have created a bolt. Now we need to connect both of them. So that is done using a topology. So I've created a new class called local topology where we will connect the both. So again, this class is the class which implements the main method. So in the main method, I'm creating a new topology, and I can define the topology. In this topology, there will be only one spout, which is the Twitter spout that we have created, which is nothing but just connecting to Twitter. Then I'm creating a bolt, the Elasticsearch bolt that we have just created. And then I also specify this bolt should be connected to Twitter spout using the shuffle grouping method. The shuffle grouping method dictates that the Twitter stream that we receive from the bolt, from the spout, should be sent to the Elasticsearch bolt in a random manner. That means any tweet could, let's say if you have multiple bolts, like let's say 3 bolts, it will send us each tuple randomly to all the 3 different bolts. Here we just have 1 bolt, so this really doesn't matter, but it is there for your reference. We could also use other methods like grouping by field, where we can send only a specific basically words or tweets to only specific bolt, and we can group it by, let's say if you want to send a tweet from a particular user only to a specific bolt, so that we can count the number of tweets per user, you can do that. You can use a field grouping method. So there you can decide all the tweets belonging to a specific user should be sent to a specific bolt, so that user can count, maintain a count of users tweets, right? But this is good enough for now. Then I create a new config object. I'm setting the debug option as true, so it will print out a lot of verbose statement during the debugging. And then I create a local cluster where the cluster is there on my remote machine, local machine itself, and I'm going to submit the topology that I just created to this local cluster using the current config that I just created. So once I do this, basically the topology will start running, and it will keep running as long as my main program is running. And I'm saying run it for 10 seconds only, and after 10 seconds I'm going to shut down the topology. So what will happen is, once the topology comes to life, it's going to connect, it's going to start running our spout, where the spout will connect to Twitter stream. It will keep getting tweets for the next 10 minutes, and it will send to the Elasticsearch bolt, which will then write to the Elasticsearch for the next 10 seconds. Okay, so before we run this, I am going to clear my Elasticsearch index, so that we will start with a clean slate. So I'm going to delete the Twitter index. So now there is nothing, there is no index. So I'm just creating an empty index first. Let's look at the number of documents now. So there are 0 documents now in this particular Elasticsearch, right? Because it is 0, and I'm doing a match all. So there are no documents in the Elasticsearch at this point. Now what I'm going to do is, I'm going to run this topology. As I run this topology, you will see a lot of messages in the console below, which will tell me that how my topology is being processed. Okay, and then we will also go back to our Elasticsearch to verify if there are any documents which are indexed. At this point, there are 0 documents in the index. So I'm going to run this topology. I'm just going to click run. So you will see a lot of debug messages that are being printed out. So it's running now. It's connecting to Twitter, and it's getting all the tweets. And it will run for 10 seconds, and then we are going to shut it down automatically. Okay, so the process has shut down successfully. Let's look at few messages in the console. So you see that there are around 155 documents have been inserted. It gives me the document ID of the document that has been indexed. So these are some of the tweets that we are showing it here. So this is the entire tweet object, right? This is the user. These are the text of the tweet. So we are getting all the information from the Twitter, and then we are inserting into the Elasticsearch. So our topology has been running successfully. So now let's rest, and the documents are getting indexed in real time. So you can see the 155 documents appear in our Elasticsearch, and you can immediately start searching. So let's say if I'm searching for COVID-19, so you will see we are able to search in the documents, and we got about 109 documents in which the COVID-19 is present. And these are some of the tweets, like if COVID-19 was a person, COVID-19 is really upsetting me and my home girls. Then there is some other text in some other language, but COVID-19 is there consistently, right? So as you can see, the documents are getting indexed in real time as soon as we start our topology. So this is how we implement the real-time search. So the next thing what we are going to do is so far we had just one Elasticsearch and one bolt, but we could also configure multiple Elasticsearch and multiple bolts. Let's do that next. Now let's say instead of one bolt, you want 3 bolts to process that in parallel. So you just add another parallel number of bolts. It's a hint to the Twitter. Let's say I'm going to add 3 bolts, right? And one so that we can we can start writing to the Elasticsearch in parallel during those 10 minutes. So this will increase the speed with which you write the Elasticsearch, but rest of the things should just work as usual, and we can still do shuffle grouping right now. So let's run this. You shouldn't see any difference in the functionality, but just going to run this. So let me delete the index as usual. Create the new index and ensure that it's blank. So there is no documents, 0 documents. So I'm just going to run this. So this time we have 3 bolts, 1 spout, and I'm just going to run this. It should just run as usual. The only difference that it should process a lot more documents, because we are still going to run it for 10 seconds. Earlier we had about 120 documents. Now since we are running 3 bolts at a time, I should see a more number of documents in 10 seconds. So let's do that. So the topology is running now. Okay, so it's done. Let's see how many documents it has processed. So I can see that by searching for the doc num. Should be there somewhere here. Okay, this is 46, but I'm going to check it myself. So 145, right? So as you can see, it has written a lot more documents as compared to earlier, which had only 120, because we had a lot more bolts running. So again, we can do similar search, and our first search functionality remains as it is, right? So this is how you increase the parallelism and improve the processing speed by adding more number of bolts in your system.